Welcome, dear students. The topic of today's discussion is formal charge. In the chapter of the chemical bonding, we have already discussed the different Lewis structures, and now the topic is about the formal charge, how we can allot the charge to an individual atom in a molecule or ion. My dear students, the formal charge that is very formal, that is basically a fake hypothetical charge which is given to atoms in a molecule just to study the distribution of the electric charge within a molecule. This one is not an actual charge because the formal charge is the charge which is given to the atoms in a molecule or in a ion, while the actual charge is basically the overall charge that a molecule or a polyatomic ion possesses. So it is not an actual charge, it is just a bookkeeping procedure. What is the definition of formal charge? Charge assigned to an atom. So basically this is charge which is assigned to an individual atom in a molecule or in a polyatomic ion, assuming that, so there is an assumption, and keep in mind this assumption is very important because on the basis of this assumption we differentiate between the formal charge and oxidation states. What is the assumption? That electron in all bonds are equally shared between atoms. When we say that electrons in all bonds are equally shared, it means we are ignoring the electronegativities of the atoms. Otherwise, in covalent bonds, the shared pair of electron, they are sometimes not equally shared because of difference in the electronegativities of the atoms. But in this case, when we are calculating the formal charge on an atom in a molecule or in an ion, we will ignore the electronegativities of the bonded atoms and we will assume that the electron pair is shared equally between the bonded atoms. So what is assumption? Assumption is that electronegativities of the bonded atoms will be ignored. What is the formula to calculate the formal charge? Formal charge is equal to V minus N minus B divided by 2. V is the valence electrons, N means non-bonding electrons or lone pair of the electrons, and B is bonding electrons. When you are dividing B by 2, when you are dividing bonding electrons between two atoms, it means this formula is also showing that the bonding electrons will be divided between two atoms equally. It means again this B by 2, it shows that bonding electrons will be divided between the atoms equally and their electronegativities will be ignored. Another formula is that formal charge is equal to group number minus number of covalent bonds minus number of electrons in lone pairs. So this one is another formula. I am mentioning different formulas to calculate the formal charge just because of the reason that sometimes in the MCQs multiple choice questions only the formulas are asked. So you must have idea of the all formulas which are used to calculate the formal charge. How we will practically calculate the formal charge, that is another thing. We will calculate the formal charge. We can calculate the formal charge by using any of these formulas, but you are required to memorize these formulas in case they are asked in the MCQs multiple choice questions. There is another definition of formal charge. Difference between number of electrons in elemental state and number of electron assigned in Lewis structure. It is basically the difference between the number of electrons in elemental state. Mean in the form of ground state, an element possesses how many valence electrons? That will be the number of electrons in elemental state. Just like the carbon possesses 4 electrons in its outermost shell in the form of in its ground state, so its number of electrons in elemental state, that will be 4. Nitrogen possesses 5 electrons in its outermost shell in ground state, so the number of electron in its elemental state, that will be 5. You can say that the number of electron in elemental state, that is basically the number of valence electrons, and they are equal to the group number of that element. And number of electron assigned in Lewis structure, how many electrons you have given to that atom in the Lewis structure, that difference mean number of valence electron minus number of valence electron around atom in a molecule. That difference will also provide the concept of the formal charge. Why do we calculate the formal charge? Because it is fake, it is hypothetical. Then what is its importance? My dear students, formal charge is inversely proportional to stability. Mean if the formal charge will be greater, then that structure, lever structure, will be considered as unstable. And the lever structure having least formal charge will be considered as the most stable. So if a molecule has two or three lever structures, we can easily mention that this one is the most stable and this one is the least stable lever structure according to the formal charges on their atoms. And then that lever structure is given most importance, which has least formal charge and which has highest stability. Now we will find the this concept that how the formal charge is related to the stability. We are going to take the example of the CO2 basically. Dear students, these are the three resonance structures of the carbon dioxide in front of you. Now we will assign formal charge to every atom in these three structures. But before assigning the formal charge, keep one thing in your mind that if any lever structure is written in front of you, you will first divide the bonds into two halves. So first of all, divide the bonds into two halves. After you have divided the bonds into two halves, now let us apply this formula, which is the easiest one to calculate the formal charge. First of all, let us calculate the formal charge of these oxygen atoms in structure 1. So in structure 1, this one is the structure 1. This oxygen has formal charge. Oxygen has how many number of valence electrons? That is equal to its group number. It is 6A. So it will be having 6 valence electrons minus number of electrons around atom in the molecule. Now this oxygen atom has how many electrons in this lever structure? 1, 2, 3, 4 and 5, 6. Because these two electrons, they are shared by the carbon. They do not belong to oxygen. So that's why we have cut the bond into two equal halves so that we may assign those electrons to an atom that actually they are belonging to that atom. So this oxygen has 1, 2, 3, 4, 5, 6. It means it is having 6 electrons. So its formal charge will be equal to 0. And you will write down 0 here. Now, this oxygen is just 100% like the other oxygen, so it means its formal charge will also be equal to 0 because it is a member of group 6A and there are 1, 2, 3, 4, 5, 6 electrons assigned to this oxygen, so its formal charge will be 0. Now, let us calculate the formal charge of this carbon. Dear students, the formal charge of carbon is the number of valence electron in carbon are 4 minus how many electrons are assigned to this carbon? 1, 2, 3 and 4. So its formal charge will also be 0. In structure 1, all three atoms they have formal charge equal to 0. Now let us see the structure 2. In structure 2, first of all, let us calculate charge of this oxygen. It belongs to group 6, so number of valence electrons are 6 minus 1, 2, 3, 4, 5, 6, 7. The 7 electrons are assigned to it, so its charge should be equal to -1. And now this oxygen, let us calculate formal charge of the other oxygen atom. It has 6 electrons in its valence shell and number of electrons around 1, 2, 3, 4, 5. So it will be having +1. And now what's about the carbon? My dear students, carbon belongs to group 4. Number of valence electrons are 4. And how many electrons are assigned in this lever structure to carbon? 1, 2, 3 and 4. So that will be 0. It means in this structure 2, this oxygen will be having formal charge -1, this will be having formal charge of +1 and carbon will be having formal charge equal to 0. But overall charge, the actual charge in that case, that will be 0. These are just the hypothetical or fake charges which are given to these atoms. Actual charge is the overall charge of that structure, and in that case even the overall charge that will be 0. and that will be its actual charge. Now let us talk about structure 3. This was 2. Now we are going to talk about the structure 3. My dear students, in this structure 3, let us first calculate formal charge of this oxygen. 6 valence electrons minus electrons assigned 1, 2, 3, 4, 5. So it will be plus 1, just like this oxygen. Carbon, again 4 valence electron minus assigned 1, 2, 3, 4. So its formal charge will be 0. And the formal charge of this oxygen will be 6 minus 1, 2, 3, 4, 5, 6, 7. It will be minus 1. These will be the formal charges of atoms in structure 3. Now, the formal charge is inversely proportional to stability. It means this structure 2 has formal charges on the atoms that will be relatively unstable. Similarly, the structure 3 also has some formal charges on the atoms that will also be unstable. But this structure 1, it has all neutral atoms, so the formal charges in that case, they are minimum. As the formal charges in this structure, they are minimum, so its structure should be having highest stability. That's why this structure is most accepted structure, because of the highest stability of this Lewis structure due to minimum formal charge on the atoms. And that's why in the books, whenever you will see this Lewis structure, not these one, as they are the unstable with respect to their formal charges. Now let us look into some more examples. Like, if you want to calculate the formal charges on water, this one is the Lewis structure of water. Again, you will write down the bonded electrons, and you will divide the bonds into two halves. Now let us calculate first of all formal charge of oxygen atom. The number of valence electron in oxygen are 6 minus the number of electron allotted 1, 2, 3, 4 and 5. So it should be having plus 1 formal charge. Sorry, the number of electrons allotted are also 6. 1, 2, 3, 4, 5 and 6. So it should be having 0 formal charge. Now what's about the hydrogens? Hydrogen belongs to group 1A. So 1 electron is in its valence shell, and the number of electrons allotted in this Lewis structure, they are also 1. So it will be 0. It means all atoms in water, they will be having 0 formal charge. Now let us calculate the formal charge in carbonate ion. This one is one of the Lewis structures of the carbonate ion. Again, you will allot the lone pairs of electron. It will be having 2 lone pair, and these atoms, they have 3 lone pairs of electrons. This one is the Lewis structure of the carbonate ion. Now mention the bond pair of the electrons. And again divide the bond into 2 equal halves, ignoring the electronegativity. Calculate the formal charge of this oxygen. It is group 6 member, and how many electrons are allotted? 1, 2, 3, 4, 5, 6. So its formal charge will be 0. Now the formal charge of this oxygen atom, 6 minus 1, 2, 3, 4, 5, 6, 7. So it should be minus 1. In the same way, the formal charge of this oxygen, 6 minus 1, 2, 3, 4, 5, 6, 7, it will also be minus 1. And formal charge of carbon, 4 minus 1, 2, 3, 4, 0. So its formal charge will be 0. It means the formal charge of this oxygen and carbon both are zeros. The formal charge of both these oxygen is -1 each, and the overall actual charge that will be written on this carbonate ion, that will be -2. This -2 written here, that is the actual charge. But these -1 and -1 which are written here, they are basically the formal hypothetical fake charges on the atoms, just to study the electric distribution on the electric charge distribution on the atoms of the atoms of the molecules. So -2 is the actual charge. These are the fake charges, and these charges, they just decide the stability of the respected Lewis structure, and they also decide the overall electric charge distribution on the atoms of a molecule. And similarly, now I am giving you some assignment. You are required to calculate the formal charges on 3 oxygen atoms of ozone, on nitrate, and on sulfate. I will also post the answer of these formal charges, but you are required to calculate the formal charges on all atoms in these three molecules. One ozone, second is the nitrate ion, and third is the sulfate ion. And you are required to mention their answer in the comment section. I will also post their answers in the form of a post. I will calculate their formal charges actually. Next time we will come up with some new lecture. Till then, take care.